Okay, guys, so last time I started to explain how can we analyze a sequential circuit. Okay, that means I will give you a sequential circuit, something like this one, and then I ask you to analyze it. So what it means analyze it? It means given this circuit, you have to find the what we call a state table, and also you have to draw the state diagram. Okay. As I told you last time, this is similar in case of combinational circuit. It's similar if I give you a circuit and then ask you to make a truth table. But here in sequentials, we don't call it truth table. Instead, we call it a state table. This one here. And it's little bit different from truth table. It's almost the same, but small difference. Okay. Also, instead of making timing diagram, we have a state diagram here. You got what I'm saying? This is the analogy, an analogy between sequential and combinational circuit. Last time I told you how can you do it? How if okay, because this will be in test number 1. So in test 1, I will give you a circuit like this one. I will ask you to analyze it. Also, the coming lab, which by the way is the last lab. After that, the last 2 weeks, you are gonna work on project. So in the coming lab as well, I will also give you a circuit to analyze. Okay. So the first thing you have to do is look here. You have to see here. I have 2 flip-flops as you see here. One flip-flop, the second one is another flip-flop as you see here. Okay. Here the Q, because I have 2 flip-flop, I'm not gonna call it Q and Q, otherwise I will be confused. So I'm gonna call it A and B. So A here means Q, this is Q for flip-flop A. Okay. B is actually Q for flip-flop B. Okay. And then in order to make this table, the table has input and output. The input here, as we see, we start by present state of the flip-flops you have, A and B. And also we have here one input, we have one output here. So here in this part here in the table, okay, you have to write the Q values for the flip-flops you have and the inputs. Okay. In this case, I have only 2 flip-flops, that's why I'm gonna say I'm gonna write here A and B. I have only one input, so that's why I'm gonna put X. Okay. Maybe in other circuit you're gonna have 3 flip-flops, so it's gonna be A, B, C. Maybe you are gonna have 3 inputs, so X, Y, Z, and so on. Whatever inputs you have, whatever flip-flops you have, you put them here. Okay. And then here you have to write all possible cases similar to what we did before in combinational circuit. Okay. So here as we see, 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 1, 0, 1, and so on. So this part is it's almost similar to what we did before, but here what we did before, we only put the inputs, but this time you have to put the input. Also, you have to put the flip-flops. Okay, we call it the present state. This is a time chain. Okay. Now we need to, in order to finish this table, I need to calculate what is the negative state for A and B. So you can see here the flip-flops, I put them in the input and also I put them in the output because this is the current state and this is the negative state. Okay. Negative state means when clock comes. So when clock, every time there is a clock, this flip-flop should change the state at every clock. Okay, based on the input you have here. Okay? The output may change, or maybe you are going to get the same output. Okay? So this update is going to happen always. Okay, every clock is going to be updated. Okay? And if again update doesn't mean A and B have to change. Okay, but a new value will be calculated. It can be the same value, but the calculation is going to happen every clock. Anyway, so now so this part is okay. All what you have to do here, you have to put all flip-flops you have. You have to put the input here, and then you have to put all possible cases here. That's very easy part to do. In the output, also you have A and B, but this is this is the new value for A and B. Okay, when clock comes. So that means if A is 0 and B is 0 and X is 0, okay, If this is the current state and a clock comes, the new state is gonna become 0, 0, okay, and y is 0. That means if I'm in state 0, 0 and x is 0, I will stay in the same state, 0, 0. That's the meaning of it. Okay? But for example, if I'm here, if I'm in state 0, 0, but x is 1, so next state will be when the clock comes 0, 1. Okay? So now the question, I'm just explaining the meaning of this table, but now I want to explain, and that's what you have to do. You need to calculate this part. So how can you calculate this part? Very simple. All what you have to do, you have to find one equation for A, one equation for B, one equation for Y. And the equation of A should be function in ABX. Okay? Don't be confused between this B and this B. Okay? I'll take A and this A. Actually, A and B here, this is the state of type G. This is the new one, new state. Okay? Anyway, so here, so now the question is, how can you find this equation? So now I need to find the equation for the new value of A, and this equation has to be function in the old value of A, the old value of B, and X. Same thing for B, same thing for Y. So how can you get these equations? As I told you last time, number one, to get this equation, you need to calculate the input of the flip-flops. It's just a general rule. Here in this example, I use deep flip-flop. I have four examples here. Today I'm going to explain the 4 examples. So I'm going to use different flip-flops, but I will follow the same steps. So here, number one, you need to calculate the input of each flip-flop. Once you calculate the input, I can easily calculate the output. Why? Because as I explained before in flip-flop, I have what is called characteristic equation. What is the characteristic equation? The characteristic equation should give you the relation between input and output of each flip-flop. So what I have to do is, I need to calculate the input, and then once I do the input, I have to plug in the characteristic equation to get the output. Again, characteristic equation, as I explained before, if I go back, yeah, for example, here here in T flip-flop, this is T flip-flop. In T flip-flop, this is the characteristic equation of this one, okay, which is the new value Q T plus 1, the new value for Q, okay, should equal T, the input T, executed always the Q. This is a time T, and this one at a time T. So this is the value of T, value of Q. This is the new value of Q when the clock comes. Okay. Same thing for the other ones. So this is for JK. Also, we have this equation. We have this equation for JK. We have also another equation. The easy one is actually D flip-flop, because in case of D flip-flop, U of T plus 1, the new value for Q equals the current value for T. That's how it works, right? If T is 0, when the clock comes, I will see 0 here. Okay, this is what we call characteristic equation. If T is 1, when the clock comes, this one is 1. That's how it works. That's how I explained it. Okay? So all what you have to do, guys, number one, you need to calculate the input of all the flip-flops. Number two, you have to plug in the characteristic equation. Again, characteristic equation gives you the relation between output and input. By this way, I have an equation for the output. Okay? And that's actually what I need here in the table. Because I need output here, I mean, sorry, A or B, okay? Which is QA or QB, okay? So let's do it here for example, let's do it for example for this flip-flop here. This one here, if this is here A prime, so A prime and X. This is the input of this one. That means the equation for this one B at time T plus 1, the new value for B should equal A prime at time T and X at time T. And also I told you last time, usually we just delete T from here, because it's already known whatever you have here should be at time T, and whatever you have here should be at time T plus 1, because it's a new value for B. Okay, so again, so that means B, this B here, this equation P is actually the new value for P is actually A prime X. That's it. So now you have X here. Okay, you have A here. You can calculate A prime and X, and then I can get this table this way. Okay. For example, here you can see here these ones are all of them are ones. A prime, all of them becomes zeros. And you know, if it is n and you have 0, regardless of the other input, the output is 0. That's why you can see here, when I have all of them are ones here, I will get 4 zeros here. Okay, why? Because A prime is actually 4 zeros. Okay. Also, you know here, if I do this one here, you have 4 zeros. A prime, this one should be 4 ones. And you know from n, 1 and x gives you x. Okay, that means here these values will be the same values I will see here. Equal. Why? Because these are ones here. Anyway, I have equation. I have here a, b, and x. I can just use this equation to calculate this. Okay, guys. This is for same thing. I can do it for A. So here for A, same thing. I will repeat it again. Here, this one is A. This one is X. This one is X. This one is B. Right? Yeah. A, X, X, B. So here, the input here is actually is A and X or B and X. Okay, I'm right or wrong? I think so. Okay. And then that means the new value for T, for A, sorry, the new value should equal to G, which is AX or BX. Let me see, I think it was maybe a mistake. Yeah, no, it's correct. AX and or BX. Okay. Anyway, so again, I can use, so this is the new value for A, so I can use this equation to calculate A here. I can calculate this from this one. Because you have here, you have A is here, X is here, B is here, X is here. Okay, I can calculate this from. Okay. Same thing, I need another equation for the output Y. Okay, so you can see here the output Y is, this one is coming from X, so this one is X, so this one should be X right. This one coming from B, this one is B, and this one here, this input is coming from A. Okay, so here A or B. Okay, so Y actually should equal X prime, okay, and A or B. That's it. You have here A and B, you have here A and B here, you have X here. You can just plug in this equation to calculate this code. Okay, guys, is that difficult? Any questions? Okay, I will give you more examples. Again, so here, I just want to explain this table again, not how to make it, but the meaning. What's the meaning of this table? Okay, you know, truth table you have input, like for example, W, X, Y, Z. This is input, and you have output F. The meaning of the truth table, every time I apply this input, I will get this output. This is the meaning of the table. Okay? So here, what this table means? It means, guys, for example, if I'm in this state, 1, 0 this way, okay, and the input was X. So the next state will be 0, 0 when the clock comes to short. That means if this one is 1, and if this B is 0, and X here was 0, okay, when the clock comes, it becomes 0. So this one was 1, okay? So the new value, this one becomes 0, this one is 0, okay? And Y here is 1. Okay? So I was here, now I'm gonna move to this state, 0, 0. Okay? Any one of these, because it depends, because I have here 2. I have 2 for 0, 0, right? 1 when X is 0, 1 when X is 1. Okay? It's just one state, but it depends where you want to go after that, depends on the value of X. Okay? So that's why you can see here, I'm gonna jump from one step to another based on the value of X. Okay? So the next step here, so now you should know the characteristic equation in exams. I will ask you to write what we call a state equation. A state equation are the equation for the flip-flops. These equations I calculated. Also, I will ask you to give me the output equation. It's the equation for the output. Now, if you have this table as you see here, now I wanna draw this state diagram. I will show you how we can do this state diagram. The first thing you have to do is, now I have two flip-flops, okay, A and B. So how many states I'm gonna have? If you have two flip-flops, there is a relation. Number of states should equal 2 to the power of n, where n is the number of flip-flops, okay? Here we have two flip-flops, that means we have 4 states. So the first thing you have to do, you have to make a circle. You have to make 4 states, circle this way and put 0, 0. So this is these two numbers here for A and B. When A is 0, B is 0. Okay? I'm gonna make another circle here, 1, 0, 0, 1, 1, 1. This is the first state I have. And then, based on the values I have here in the table, I need to do this arrows here. I need to know if I'm in state 0, okay, is next. You see here, if I'm in state 0, okay, 0, 0, so it may be I'm gonna stay here, or I'm gonna come here. So there are 2 arrows for getting out from each state. One of them, when x is equal to 0, the other one is when x is equal to 1. Because x can decide to which state I will go. Okay, so as you see here, guys, on the arrows here, you can see 2 numbers. One number here is the input x, and one number here is y. Okay, I will give you more details, but this is how it is. Same thing here. If I'm in state 1, 0, as you see here, maybe I'm gonna stay here, or maybe I'm gonna come here. Based on x. This is when x is 0, this is when x is 1. How do you get this information from the table, as I will show you right now? So let's start here, show you how after you make the 4 circles, how can you draw the arrows here, okay, from the table. So you can see from the table here, guys, if I'm in state 0, this is the input as I told you, if I'm in state 0, and x is 0. So the next state should be 0, and y is 0. So let's do this one here. Okay. Again, if I'm 0, state 0, I'm gonna stay state 0. That's why I'm gonna keep this one. But this happens when x is 0, and the output is actually 0 as well. This one and this one. So all what you have to do is, this is x, you have to move x here. This is y is here. Okay. And this is the arrow, it's gonna start from 0, 0, it's gonna go to this one. I will repeat everything for all of them. Okay. So now let's do the second one here. If I'm in state 0, 0, and x is 1, so next state is actually 0, 1. So that's why, as you see here, I have to make a line. I have to make a line this way. And okay. That means if I'm in state in 0, 0, I will go to state 0, 1. But this happens when the input is here 1, the input x here is 1, and in this case, the output y is 0. So always here, this number is x, this number is y. So you can see here, if you are in one state, and between the value of x, I'm going to move to this state. Okay, when the clock comes, again, the move from one state to another, it happens when the clock comes. So every time there is a clock, you are going to move from one state to another. Or maybe I'm going to stay in the same state, depending on what input we have. But the changes happens, okay, only at the clocks. Okay? Same thing here. I'm using colors. The use of colors is easier. So how can I draw this two here? As you see here, guys. Same thing, I will just repeat it. If I'm in a state of 0, 1, if I'm in a state 0, 1, okay, and the x is 0, so the next state becomes 1, 1, and the output is 1. Okay? That means I need to make an arrow. I need to make an arrow from state 0, 1 to 0, 0. Yeah, from 0, 1 here to I need to make an arrow this way. Also, I have to say when this happens. It happens when x here is 0. Okay, when x is 0, because when x is 1, it will be a different case. Let's see here. If I'm in this state, x is 0, I will come to here. But if x is 1, I will come to here. So I have to say, if I'm in this state, x is 0, I will go to this state. Okay, from the table. I just get it from the table. Okay? So the next one here, if I'm in state 0, 1, okay, and x is 1, so I'm gonna go to from 0, 1 to 1, 1. This is exactly what I did here. From 0, 1 to 1, 1. This happens with x and 1. Just copy x and 1. That's it. Okay, guys. Same thing for the other ones here. So if I'm in state 1, 0, okay, then I will go to state 0, 0. Yeah. So as you see, this is the error I did here. Okay. If I'm sorry, this is state. Sorry here. Yeah, 1, 0. I'm moving to 0, 0. Yes. This happens when x is 0. X here is 0, and at this time 1 is 1. Okay. Same thing here also. When this one is 1, 0, and I'm gonna move to 1, 0, so no change. I will move to myself, or as you see here, so transition to itself. I think this happens when x is 1. Okay, guys. Here, because I have only one input x, so for every state, there should be 2 errors. 1 when x is 0, 1 when x is 1. Make sense? What if I have 2 inputs, x and y? I have 2 inputs, okay? Or w and x, for example. What if I have 2 inputs? What do you think? What is going to happen? There should be 4 errors out of every state. Because if I have 2 inputs, I'm going to have 4 different cases. What I'm saying? So that means if I'm here, maybe next time I will come here if the input is 0, 0. Okay? But if I'm here, I will, for example, just but I just want to show you here, there should be 4 errors because now the input, I have 4 cases for the input, not 2. Okay? Yes.
So if you changed it to 2 inputs, would you then have to expand the amount of, would you have to expand the state part?
That's a very good question. Okay, so the question is, if it is 2 input, should I have more states? The answer is no relation between input and states. The number of states is related to the number of flip-flops you have. It's not related to the number of inputs. You got what I'm saying? So here, as long as we have 2 states, sorry, 2 flip-flops, I should have 4 states, regardless how many inputs I have. Okay, guys? Yeah. So after you finish all of them, that's it. So this is what I need to find is this table, and also I need to find the state diagram. I will give you 3 more examples. Same thing, I just repeat, okay? Just to understand it more. But I want to tell you here in the text book, if you have the state table as we calculated it, you can directly, as I have just explained, you can directly draw the state diagram from the state table directly, similar to what I did. Okay, so every row here, every row is going to be represented by 1 arrow here. Okay. But there is another way you can do it. You can take this table and you can make another table here and move from this table to the. This table is almost similar to this one, but I just changed the format. So again, what I'm saying is that if you have the state table in this format here, you can just move directly from here to here, or as mentioned in the text book, you can actually using this table. I can just change the format. I didn't change things. I will show right now. Just change the format. Just just maybe easier to move from here to here, but I think it's easy to, there is no need to make another table. In my opinion, it's not difficult to move from the table to here. You don't need to make changes format. I will show you. So here I didn't do any other calculations. I just changes the format of the table. Okay, but you see how what I did here. Okay, right? Now these two here, these two states. Okay, this is when the input is 0, 0. Okay, so this one is going to be represented by only one row. Okay, how you make it? I will tell you how. So here you can see we have here 0, 0, so that's why we have state 0, 0. Okay, and then here I'm going to have next step is going to be twice. One when x is 0, one when x is 1. So this is when x is 0, and this one when x is 1. Okay, so when x is 0, x is 0, 0, so I'm going to put here 0, 0. Okay, and y is 0, same thing for output. So I'm going to make it here when x is 0, when x is 1. Okay, that's why that's what I'm saying. I didn't do new calculations. All what I did, I just changed the format of the table. So every 2 rows, okay, I just make it here in 1 row. Okay, it's exactly the same thing. Here, if it is 0, 0, when x is 0, so here I'm gonna next step, I'm gonna make it twice. One time when x is 0, one time when x. So here when x is 0, so I'm gonna pick 0, 0, I'm gonna put it here. And here, when y equals 0, when x is 0, so I'm going to put here under x is equal to 0 here. Okay. Same thing here, when x is 1, I will take this one here, I put it under here, 1. I'm going to take the output here, I put it here under 1. Okay. So I just changed the format of the table so that you can see here, if I'm in state 0, 0, okay. So next state will be 0, 0 when x is 0. Or it is when 0, 0, next state is 0, 1 when x is 1. You can accept again. I will not ask you to make this, it's up to you, but just I put it just in, if you see it in, I'm not sure if Zybox is using it or not, or but it is in the text box. But again, there is no difference between these two tables. My advice to you, or what I recommend, I wouldn't ask you to give me, just it's not difficult if you have the state table, just to move it from here to here. But keep in mind, every row here you have here is going to be represented by one error. Every row, one error. Okay? Any questions? I will give you 3. I will repeat again. So I will give you 3 more examples to understand it better and more. Okay? Let's have this circuit here. I give you this circuit and I want to analyze it. Okay. So number 1, we are using D flip-flop as you see here. This is number 1. Number 2, you can see here we have 2 inputs, x and y. We have 2 inputs, x and y. Okay. And the output of this circuit is actually taken from A. This is also one of the possible cases. So I don't have, if I go back, I just want to compare this one to the previous example. In this example, number 1, the difference is number 1, here we have only one input x, but the example number 2, we have two inputs. This is one difference. Second difference, here we have 2 flip-flops. This example, we have only one flip-flop. Okay. One more difference, important difference is here I have a combinational circuit to calculate the output here. But in this example, I don't have something like that. So if you don't have a combinational circuit to calculate y, that means the output of the circuit are going to be taken from the flip-flops. So let me see it again. Sometimes, guys, the output of the circuit is taken from a combinational circuit, something like that, and then I get the output. Okay? Sometimes the output of the circuit is taken from the output of the flip-flop. You get what I'm saying? That's why here we don't have output. Maybe I don't want to misunderstand when I say no output here, it doesn't mean there is no circuit that doesn't have output. Okay? There is no circuit that doesn't have output. So when I say no output here, I mean the output is not taken from a combinational circuit. That means the state here, this is the A here, this also, this will act as a state and also output at the same time. You understand what I'm saying? But we don't have output is calculated from a combinational circuit. Anyway, let's see how can we analyze this one. Number one, how can you make the table? When you make the table, number one, you have to put the flip-flops you have. I have only one flip-flop A, and then you have to put the inputs. You have X, Y. Is that okay? You have to put all inputs and flip-flops you have. Okay, and then you have to put all possible cases. Okay, and what should I put here as output? I have to put also the flip-flops, but because this is at time t, this is the new value at time t plus 1. Okay, and if any output you have, I don't have any output here because the output will be the same like A. I don't have a special output calculated using combinational set. That's it. So this is how the table will look like. Is that okay? So all what I need to calculate only A. How I can calculate A? Similar to what I explained to you before. You need to find an equation for A. And to find the equation for A, I need to find the input here. And once you find the input, you can use the characteristic equation to calculate the output. Okay, so let's see. This is A. This is X to produce of or Y. So the input here is actually X to produce of or Y, X to produce of or A. This is the input here. And you know the characteristic equation of T flip-flop, the output A at time T plus 1 is actually equal to T at time T. That means the equation I have to use it here, equation is X to produce of or Y, X to produce of or C. Okay? And the way you have to calculate it, you have to do twice. So I have to calculate the exclusive port for X and Y first, and then the result you do it with C. Sorry, what is it? A, sorry, so here you have A, X, Y. Okay. So this is how I make it here. Yeah, so here, this is the inputs that I told you guys. I put A, X, and Y. I put all possible cases. I'm using this equation. The equation I found it here, and I can fill up. This column. Okay. Now I'm done. Now, if you look at how can you draw the state diagram? Because I have only one flip-flop. How many states I have? Only 2 states. So now I have one circle with 0, one circle with 1. Is that okay? But here, because I have 2 inputs, that means, and I have here, you know, as we did before here in the arrow, you have to put inputs and then slash outputs. But here in this case, I don't have output because the output is taken. When I say output, it means output is calculated using combinational circuit, similar to what we did in the previous example. But here, the output is taken from A, so I don't need to even put a slash this way. Just to give me the input. Okay. So I will show you how we do it here. Yeah. Look here how I make it, guys. Here, when X is 0 and X and Y 0, 0. Look here. So for everyone, there are four possible cases, right? So here, when X is 0, okay, next time I will go to 0, but this should happen when X and Y are 0, 0. That's why you can see here, guys. If I'm in state 0, and then I have to go back to 0 again when the input is 0, 0, 0. Is that okay? Also here, see the second one here. If I'm in state 0, I have to go to state 1. Look at this one here. If I'm in state 0, I have to go to state 1, and this should happen when 0, in case of 0, 1. Because for the input, I have four different cases. Okay? So if I'm in one state, okay? So I have 4 different cases. One case when it is 0, 0, one case when it is 0, 1, one case when 1, 1, and 1, 1 or 1, 0. Is that okay? So I will move from here to here. So if I go to next one here, it's the same thing. If I'm at 0, I will go to state 1 at 1, 0. So that means 1, 0 is here as you see here. Okay, I don't need to make another, I don't need I don't need to make another arrow here and say 1, 0 and remove it to here. It's enough, I can merge them together and say, and that's exactly what I did. So if I'm here, if I'm in 0, I will go to 1 when the input is 0, 1, or the input is 1, 0. You know what I'm saying? So I merge the two errors. There is no need to make two errors here. So this is the meaning of it. So the meaning of it, if I'm in state 0, I will go to state 1 when the input is 0, 1 or 1, 0. And you can see it here. So when the input here, if I'm in 0, I will go to 1 when the input is actually 0, 1. Also, if I'm 0, I'm going to go to 1 when the input is 1, 0. Okay. There is no flash. Don't be confused. You may be confused. Is that input or output? Very simple. If there is a flash, okay, anything after the flash should be output. Anything up before that is input. Okay. This comma means or. Okay. So let's see here. Same thing here, guys. If I'm in state 1, I'm going to stay at state 1 when it is 0, 0. Yeah, that's what I did here. State 1, I'm going to stay here at 1 when it is 0, 0. Okay? Let's see another one here. If I'm in state 1, okay, I'm going to go to 0 when it is 0, 1. Okay? That's what I did here. When it is 0, 1. Okay? Let's have another one. Okay. Now, if I'm in 1, I will go to 0. If I'm in 1, I will go to 0. Okay. But this time it is 1, 0. That's why I don't need to make another error. Just I can say 1, 0. Okay. The last one here. If I'm at 1, okay, I will stay at 1 when it is 1, 1. Okay, that's why you can see if I'm 1. I will stay at 1 when it is 1. Any questions? Let's see next example. It's not difficult. That's what you have to do in next lab. That will be a question. I will give you a circuit like the 4 circuits you have here. I have 4 examples. Okay, I'm just repeating so that you can understand it. Okay, guys, any question? Yeah. Now I will go to JK flip-flop. JK flip-flop is difficult. It's a little bit difficult than G flip-flop. You know why? Because in case of GK flip-flop, number one, I have to calculate the input, 2 inputs. So I have to calculate what value we have here, what value you have to here. That's number one. Not only 1 input, 2 inputs. Okay. Number 2, the characteristic equation is somehow big one. Okay. So that's why, other than that, everything almost is the same. Okay. In my opinion, the easiest one is G flip-flop. In my opinion, if you have the choice and you are making a design, it would be easier if you just use G flip-flop. The reason G flip-flop is maybe the easiest one is because the characteristic equation is easy. Just the Q is equal to G. That's it. Okay. But I will show one example here. I still have 2 examples. One example I will G flip-flop. So next example after that, I'll show one example for T flip-flop. Okay. All of them exactly the same thing, but in case of T flip-flop, you have only 1 input, but you have to use the characteristic equation of the T flip-flop, okay? Which is, this is the characteristic equation. Okay? That means after I calculate the input here, I have to plug in here to get the equation. Anyway. Okay. So let's do it this one. So here, as you see here, guys, in this circuit, how many flip-flops you have? I have 2 flip-flops. How many states you have? I should have 4 states. So you should have 4 states. Okay. How many inputs you have? I have 1 input, which is X here. How many outputs you have? I don't have any outputs. But be careful when I say I don't have any outputs, I mean I don't have output coming from a combinational circuit. Okay? That means I don't need to add 1 column for the output because actually in this case, the output will be taken from the state themselves, can be. That's the meaning of it. But I don't need the circuit doesn't have an output because there is no circuit that doesn't have an output. Okay? But that's what I do. So there is no special output I need to add to the table. Okay? So now, if I want to make the table, how the table should look like? Very easy. Similar to what I did before. Number one, you have to put the flip-flops, you have EB, and then you have to put X, and this is your inputs. This is the inputs. You have to put all possible cases here. Make sense? Okay. What about on the other side? The other side is still you need to put the flip-flop. And then I don't have any output, so I'm not gonna put anything else. Just A and B. That's it. That okay? This is how it looks like. Now I need to find one equation for A, one equation for B. That's it. Once I have equation for A, equation for B, I can use this equation to calculate this column and this column. That's it. Make sense? How the state diagram looks like? Number one, because I have two flip-flops, I should have four statements. 1 for 0, 0, 1, 2, and 3. Okay. I can change the order, by the way. Sometimes, if it is like something complex, you can. It doesn't matter. You can, for example, you can put here 0, 1. It's not any different. And put here 1, 1. You can change the order if it can make the figure looks nice. Nice. Anyway, so number 2, how many? To change from one step to another, there should be 2 arrows, okay? Because I have here one input, X. That I'm saying. So based on the value of X, maybe when X equal to 0 will come here, when X is equal to 1 come here. It's not always it have to come to the step. It's not always like that. It's not on the circuit, sure. Yeah? So this is how it looks. So now, in order to proceed, I need to find equation for A and equation for B. Okay? To find the equation for A and the equation for B, as I told you before, number one, you need to calculate the input G and K. Number two, you have to plug in the characteristic equation of GK flip-flop. That's it. But it's gonna be somehow bigger. Okay, so let's do it. For example, here, if you look at J is actually coming from B. So G here is equal to B. Okay. Let's look at K. What is K? Okay, here, this one is X prime and this one B. So it is B and X prime. This is K. Okay. Now this is the characteristic equation here. The new value for Q should equal J Q prime. Q here is A. Okay. So here Q, any Q here is A. I just call it A because I have two flip-flops. If I say Q, I don't want to say Q1 and Q2, okay? So that's why Q here, A. So here when I work on the first flip-flop, so here this Q is actually A. When I work on the second flip-flop, this Q is actually B, okay? So anyway, so all what I have to do, guys, is here, this one Q prime should be A prime. And always remember, this is uptime T, and this is the new value for Q. Q here is A actually. So this is the new value for A. This is the new value for A, and this is the old value. So you have this old value, this is the new values for A. Okay. Anyway, so here you also see I already calculated J. So here I calculated J, which is equal to B. I will put it here. Also, I already calculated K, so I will put it here, prime. What I'm saying, that's what I did. So number one, as you see here, guys, I calculated here GA and GK. That's what, sorry, GA and KA, because I have two flip-flops. So I have to calculate for each one of them. Yeah. So this is for flip-flop A, this is for flip-flop B. So in flip-flop B, you have here, this one is X, so X prime, and this one here is actually A, and this is X. So A is X. Okay. So you have to pick number one, and even in exams, I will tell you, number one, give me the inputs or even if I don't tell you, every step you will get points for every step. So number one, you have to calculate the inputs of the flip-flop. You have to show me the inputs. You have points for it. Okay. And then after that, you have, once I have the input here, I will put this one as a characteristic equation of A. I'm gonna put this one as a characteristic equation for B. In order to get two equations, we put this as a state equation for A and B. Okay, that's what I did. So you see here, the new value of A is actually GA A prime. This is the characteristic equation. A prime A, And then after that, I'm gonna plug in. Okay, this is GA is actually B. KA is actually BX prime. Everything is prime. Okay. So yeah, then I can use it this way. Same thing here for when you calculate B, same thing. This is a characteristic equation for flip B. So this will have to be GB, Q for B, right? Same thing here. So you have to plug in everything here to have this equation, and then you can have this equation. Once you have the equation, yeah, so once you get that, once you hear, okay, this is the inputs I told you about. This is not an essential part in the state diagram, but you need it anyway to the calculations, okay? But this the state diagram should be this the main part for the state diagram, but this should maybe help you to do the calculations. And here, as you see here, the output here we have only A and B. In order to calculate this column here, I already have the equation. I have this equation here. In order to calculate this one here, I also have the equation. Okay. So once you do that, I can calculate this one, and also I can calculate A and B. By the way, there is another way. Okay. What is the other way to do the calculation? It's just very, I'm gonna twist it a little bit. There is another way. Look here, guys. I got equation for the two input G and K. G and K, I got the equation for this one. Is that okay? So now you can see if the input is 0, 0, if already, look here. Again, let me clarify what I said. What I said, you have two options. One option, just you have already equation. From the equation, you have the input here. This one has an equation. I can use this input in the equation to calculate this follow. Same thing here. This is one way to do it. There is another way to do it. Look here, guys. You already know how access equate today. Okay, so you already know how flip-flop works, right? So if you look here, this one is 0, 0. 0, 0 in GK. What 0, 0 is doing in GK. No change. So that's why you can see here, if this one is 0, 0, so actually no change. Let's say this one here we're talking only about A. A is 0, so it's no change. So it has to continue 0. Got what I'm saying? So I don't need to get the final equation, or even maybe it's easier to swing the calculation. It's up to you. Okay. The other thing here, look here, guys. Let's look another one. Here, 0, 0, no change. That's why if this one is 0, okay, so it has to continue 0, no change. Okay. Next one. If it is actually 1, 1. 1, 1 means toggle. So if it is 0, should be toggle. It should be 1. Did you see how I made the calculations? Yeah, so either you plug in the equation, or you need to see what is the input of what is the current state of the flip-flop, and what is the input, and then you already know how to work it. You can calculate this output this way. Okay, let's have another example. When it is 1, 0, when G is 1, K is 0, that means it has to be set. That's why you can see this one is set regardless. If this one is 1 or 0, it's going to be set. Okay. 0, 0 here, no change. That's why you can see when I have 1, 1, here I will get 1, 1. Okay? Here, this one is toggle. That's why here, when this one was 1, it becomes 0, and so. You know what I'm saying? So again, you can calculate this column here from the equation, or you already know you already know the current state. You already know what is the input of the flip-flop. It should be easy to calculate the new value of the flip. Okay, guys, any questions? Okay, now let's draw the state diagram. Again, nothing here is new. It's just similar to what we did before. As I told you here, we have four states, as you see here. Every row here is represented by one arrow. So let's see here. If I'm in state 0, 0, x is 0, I will go to state 0, 1. So if I'm 0, 0, okay, this is a different color. So if I'm in 0, 0, I will go to 0, 1. So 0, 1. This should happen when x is 0. So here, the first row here is going to be this arrow here. If I'm 0, 0, I have to go to 0, 1 when x is 0. Okay? Same thing, let's see the second one, okay? When it is 0, 0, I will stay in 0, 0. This happens when x is 0, 1. Okay, 0, 0, I will stay here when x is 1. Okay, let's see the next one here. Okay, if the state is 0, 1, which is this state, if it is 0, 1, and x is 0, I'm gonna go to 1, 1. That's why you can see here. X is 0. Okay. Any questions? Okay. The last example I have here is, okay. So last example I have here, same thing. I will just repeat everything again, but this time it's for T flip-flop. Okay. Everything is the same, but this time I have to use a characteristic equation of T flip-flop. We have only three flip-flops. We have G flip-flop, G, we have JK, we have G. That's it. We're not going to use all these only three. Okay. So here, you know the characteristic equation of this one is new value for Q equals the old value of Q introduced with T. Similar to what we always do, you have to find the input. You have to find the input of the flip-flop, which is T, and then you have to plug in here for this equation. Okay? This is when, and then once you have the equation, you can just calculate the following. Okay? Or you can calculate T, and you already know how the flip-flop works. You know what I'm saying? And then once you know what is A, it's easy to calculate the new value for A, given T. Okay, I will show you now. So this is also another one. But anyway, so let's look at this circuit here, guys. How many flip-flops we have? We have two flip-flops, A and B. Okay. Also, we have here one input, and here we have one output. Okay. So because we have two flip-flops, how many states we have? 4 states. Okay. So again, same thing as I told you. Number one, you have to find the input T here. The input T, this one is X, this one is B. So actually BX. So the characteristic equation for A, the new value for A, should equal to this one here, BX exclusive or with A. Because Q here, this is here, I'm calculating for flip-flop A. Okay, so this is the characteristic equation for the first flip-flop. Okay, let's do the second one. So here the second one, T is X, T is equal to X. So B of T plus 1 should equal X exclusive or of B. Okay, so Q here is B because I'm working on the second one. Just it, once you have these two, you can fill up the columns. So let's how the table looks like. Again, similar to what we did before. We have two flip-flops, A and B, and we have input X. So here you have to put all possible cases. Okay. And then what we have here as the output, we have A, B, and we have 1. Okay. To calculate A, you have this equation here. To calculate B, you have this equation. To calculate Y, so Y should equal to A. This is the equation for Y. So Y here should equal A and B. Yes.
I noticed that there's a reset there. Do we have to factor that in?
No, because again, this I just took this one. You don't need it. Okay, I took it from the textbook. Okay, so again, what I'm explaining is the normal operation. Reset is not the normal operation. That's when you want to do reset immediately. Okay, for some reason, it's not the normal operation. It's still with the state diagram, the state table. This is for the normal when there is no reset. Okay. For some reason, the textbook put here reset. It's important at least you to answer the question that can confuse some students. Okay, guys. So here, as you see here, guys, this is the input I have. This is the output. In order to calculate A or B, okay, you have the choice. Either you can use the equations we calculated here, okay, or you can calculate TA and TB, okay. So for example, I can give you one, this one is easy here. So TB is actually X. So here TB is actually equal to X, which is equal to this one. This is TB, which is actually 0, 1, 0, 1. Okay, and so on. Okay. So again, once you know TP, it's easy to calculate. So to calculate this speed from here to here. Okay. How can again similar to what we did before. Number one, you can make an equation. You can just use the equation. Number two, you can calculate the input to the flip flop, and you know already how the flip flop works. Okay. That's what I will do right now. You already know in case of T flip flop, 0 means no change. That's why if this one is 0, I have to continue 0. It's another way to calculate this column. Okay. Now, T is one now. I know 1 means to toggle. So if this one is 0, I have to toggle it. Next one here is 0, no change. Next one here is 1. Okay. 1 means toggle, and so on. So either you get this column this way, you can just give him the input of the flip flop and give him the current value to the flip flop, you can calculate the next step. Okay? Or you can just plug in these equations. Any questions? Okay. Now, given after you need to practice, don't just read the example just using your eyes. Okay, I'm sure if you do that, when it comes to exams, you will not be able to do it. Okay, so you have to do it by yourself. Okay, and then after you do it, you check to see if the answer is correct or not. And also, I think you already have Zybox as well. This also can help you to practice. It's very easy, just straightforward. Because if you understand what I say, and if you just follow the steps, okay, that's it. It's just fixed steps, no surprises. Right? Anyway, so now once you have this table here, how I can draw this figure as a state diagram. As you know, if I have 2 flip-flops, that means I should have four states. As you see here, this is state 0, 0, state 1, state 2, and state 3. So I have 4 states. Okay. There is a small change here. Is as you see here. Here, this is the input. The input is here. Usually, when you have input, you make a slash here and then you put the output. That's what I explained before. But sometimes you put the output here inside. So you can see here. This is the state slash output. But I'm saying, so sometimes you put the output here, sometimes you put the output outside here. Based on what you do this one, I will explain it later. So here I will explain. It's not a big deal. Just this is either sometimes you put slash here or sometimes you put the slash here. So if you see here, this is the state, you are at state 0, and the output is 0. This is state 1 and output is 0. I will tell you when you have to put it output here or put it here. Okay? But there is no difference, just the location of them. But I will let you. But anyway, let's see how can I do this one. Okay? Let's again similar to what I did before. If I'm in state 0, okay, and x is 0, so next time the state has to be 0. That means state 0 has to loop, it has to loop to itself when x is 0. And the output here is 0. That's why you have 0 here. Okay. Now, if I'm in state 0 and x is 1, so I have to go to state 0, 1. That's why you can see there is an arrow here. 0, 1. Makes sense? Okay. Now, if it is state 0, 1, which is where is 0, 1? Yeah, if I'm here in this state 0, 1. Okay, and then x is 0, so I have to look to itself. But if it is 0, 1, and x is 1, it has to go to 1, 0. When x is 1. Okay. Let's see another one here. If it is 1, 0, and 0, so it has to go to 1, 0. So always you can notice here in this circuit, always when x is equal to 0, that it has to look to itself. It happens for all of them. You see here, When x is 0, it's gonna look to itself. When x is 1, it's gonna look to itself. When x is 0, it's gonna look to itself. When x is 0, it's gonna look to itself. When x is 1, it's gonna move to the next state. That's how it works. Look how it works here. So every time x is 0, it's gonna stay in the same, it's the same state. But when x is 1, so it's gonna come this way, then circle this way. Every clock, when there is a clock, so assuming x is 1 also time, x is 1 also time, okay, assume. So when there is a clock, if I'm here, there is a clock, I will come to here. Another clock, I will come to, another clock come here, another clock I come here. This is how the circuit works, right? That's why I'm telling you this circuit, if you look at the state diagram, you can understand how the circuit works. Because the state table in this diagram should explain how the circuit works, right? And I make some kind of animation here to understand what I'm saying. Assuming here x is 1 all the time, as you see it, or at least in this part, x is 1. Okay? When there is a clock, if I'm assuming I'm in state 0 here, there is a clock. Okay, so what's gonna happen is after this clock, I'm gonna move from this state here to this state. X is 1, so I'm gonna move to the next move here. X is 1, move here. X is 1, I'm gonna move here. Okay, X is 1, I'm gonna move here. Make sense? X is 0, I'm gonna stay in the same state. Okay? Can anyone guess what this circuit is doing? What this circuit is doing? It's not something useful. Yes, it's counting. Thanks, that's true. This is a counter. Okay, why it is a counter? When x is 1, the count x here is like enable or disable for the counting. When x is 1, it's gonna count. When x is 0, stop counting. Okay, you see. So here, if you have a circuit, you have two output A and B. Okay, and then now when what happens here, every block 0 0. Let me go back to here to see what happens. Here I start from 0 0 and then 1 2 3. After 3 0 1 2 3 0 1 2 3 0 1 2 3. Okay, as long as x is 1. Once you get x is 0, you are gonna boost it. Okay, you are gonna stop it. Okay, that's why at any time, if I'm in this state and you make x is 0, I'm gonna hold. I'm gonna stop here. I'm going to make x is 1 to continue counting again. Is that okay? Any questions? Okay. I think you need to study these 4 examples. They are not difficult. That's what you will do in the coming lab. That's what you will do in also in test number 1. Yeah, I think we can start that with now.
Yeah, that's all day. Yeah. Don't care.
So you have three questions. It's the two sides of the papers, okay, in the paper. But someone may solve only one side and he thinks that's it, okay? You have questions in the two sides.